Hi everyone, I'm John Pett, author, speaker, and performer.
And I'm Jeff Savilico, entertainer, comedian, and almost as much fun as John.
And together, we're on a mission to take you on a journey that explores and reveals the critical elements for you to survive and thrive within the digital transformation.
We will be here to guide you, to engage you, and get you involved.
To take your questions and get the answers from the experts and execs.
So grab a beverage, get comfortable, and get excited.
Because this is MEF Infinite Edge.
Today we've got top service and technology experts joining us to explore how edge computing offers businesses a frictionless, high-performance, low-latency experience for applications in the cloud. Starting now. Hey, can you see me? What about now? Huh? Better. Okay, nice to see you all too. Welcome back to the MEF hold on, I forgot There we go, much better. All right, ladies and gentlemen, welcome back officially here to the MEF Infinite Edge Series episode 4. I'm Jeff Savilico, your host and personal tour guide, with some pretty big shoes to fill, while my co-host, John Pett, is away.
Wait, speaking of shoes, those, I see those are my shoes. I've been looking for those.
Well, look who's back. The Jedi returns.
No, just checking in, seeing how things are going.
Oh, well, things are going pretty darn well, Johnny boy. Did you see episode 3? I mean, nailed it.
Well, I don't know if I'd say nailed it. It was okay. I'd give it a nah.
What does that mean?
I mean, come on, man. This whole disappearing act with well, come on, seriously? This is professional grade show we're doing here.
Oh, come on, bro. Listen, I'm not Houdini, all right? I get it, but I've been working on my magic. And anyway, my real talent
Don't even
is
say juggling. I mean, if you're gonna go there, most of the people watching can do that. Anyone can do that.
Really? Anyone can do that? Anyone can do that.
Yeah. Anyone. Seriously.
All right, well, 3 balls. You know, like pretty much anybody can juggle 3 balls. What about this, John? Can you do this? Huh?
Yeah, seriously. You got anything better than that? I mean, this is getting like child's play.
Okay. What about a knife, John? A big, sharp knife. Can you do that? Juggle a knife, huh?
One, Jeff? Seriously? Get real.
Oh, great. Yeah, how convenient. Your screen froze, buffering issues. You know what? Just get out of here, John. I got a show to do, okay?
Fine, but I tell you, I want my shoes back. Serious. Oh, and by the way, this is how you disappear.
All right, you know what? I can do that too, okay? I can do a little disappearing act. Whoa! All right. I'm just gonna stick to the juggling. Anyway, it's time to hit the road and continue our journey along the infinite edge. Let's start off with a quick look back at the highlights so far.
Interconnect, automate, operate, accelerate, because those are the keys.
We believe that this digital transformation journey is all about customer experience transformation and ease of doing business with our customers going forward.
Networking is cool again, right? Networking is cool again.
I think the big challenge is, how do you shift from where you are today to a new security model?
I would characterize the cybersecurity landscape as sprawling and ever evolving.
I think that's the opportunity for us to win, is really to scale more smaller form factor devices, lower cost points, to help with kind of those power users in that work from home.
Standardization is really key to growing the market and accelerating the deployment of SASE services.
We have a couple of different challenges to that. One is that the perimeter is dissolving, people are moving all over the place. The second is that threats are evolving.
SASE services are really expected to provide an optimal combination of networking and security.
The factors that are driving SASE adoption is really cloud migration and cloud adoption.
What a great recap. Clearly, we've made some interesting stops along the way. Topics like the digital transformation landscape and the challenges and opportunities of SD-WAN and SASE. Now today, we're taking things up a notch and getting our heads out of the clouds and into edge computing. In this episode, we're going to discover the key steps industry players are taking to support mission-critical emerging digital applications like AR, VR, tactile internet, autonomous vehicles, and robotics. We'll also get up to speed on efforts to provide end-to-end application performance and security orchestrated across an ecosystem of automated and virtualized networks that incorporate edge computing, 5G, SD-WAN, SASE, and other advanced digital transformation solutions. Today's awesome road trip is powered by the support of our amazing sponsors, speakers, and analysts. Please don't forget to show your appreciation by visiting our sponsor booths below and chatting up our speakers and analysts by using the chat feature to your right. They would love to hear from you. Come to think of it, so would I. You know what? Let's try this. If this is your first episode of the MEF Infinite Edge series, put a 1 in the chat window to your right. Go on, just put the number 1. Now, if this is your second episode or more, put a 2 in the chat window. You got it? Go on, put 1 if it's your first time joining us, put a 2 if it's not. I'll give you 1 more second here. All right, great. Now, let's see what companies are here with us today. Type your company name and your company name only in the chat window. Let people know you're here. Shout out your company name. Come on now, just your company name. You've got 1 more second. Go. We've got a global representation of companies registered for the series, as you can see. And no matter where you're joining from, we are so glad you're here. Thank you for joining us today. Now remember, you can continue to connect and let other attendees know you're here, just like that, throughout the episode by using the same chat feature, and we hope you do. Now, we're kicking things off with a special keynote presentation from Mo Kataba, Chief Product and Platform Officer at AT&T. We'll get his take on the incredible value at the edge, where companies can exert greater control from application data, benefit from the speeds of localized compute, and enable entirely new experiences. In this keynote session, Mo will dive further into multi-access edge compute, network edge compute, and what the future holds as these technologies join forces with 5G and 5G plus environments. But first, this message.
Data, when it moves, it has the potential to transform nearly every part of your business. But when data is siloed, slow, and people and technologies are not connected, that potential is lost. What if you could connect virtually every corner of your business, unify and accelerate the flow of data, and put it to use? AT&T helps you operate with edge-to-edge intelligence from the core of your network to the far reaches of your business. A highly secure orchestration of all the pieces you need to make data work for you. Today, our customers are using edge-to-edge intelligence to understand and serve their customers better, predictively, to move with greater speed and agility, and to scale from nearly anywhere. As your business starts to fully utilize the power of edge-to-edge, automation will help you make the right connections at the right time with the security you need. From factories, using data to signal engineers to troubleshoot a problem before it is a problem, to retailers, using a connected supply chain to boldly change their industry. By empowering our customers to connect their data to anything, to connect their data to everything, we can help you turn potential to results. That's the remarkable effect of edge-to-edge intelligence. AT&T can help you get there.
Hi, I'm Mo Kataba, Chief Product and Platform Officer for AT&T Business. It is a privilege to be on the MEF board among people that I respect, luminaries and leaders in the industry. And I'm here today to talk to you about edge computing. What is edge computing? Why does it matter? And give you my perspective on it. And thank you for the opportunity to do that. So first and foremost, what is the edge? Well, for many years, we have been on a journey of moving data loads to the centralized clouds. And what the advent of 5G has enabled is the ability to bring those workloads back from the centralized cloud to either what we call the network edge, or the edge of our network, or the customer edge, which is any business premise, no matter what industry you're operating in: healthcare, entertainment, military, smart factories, retail, etc. And why does this matter? Well, it matters because historically, the latency requirements of moving workloads into a centralized cloud were about 100 milliseconds, which, by the way, is only 1/10 of 1 second, right? That is pretty darn fast for a device to give a command, that command to travel out to the centralized cloud, the command to be triggered, and then the data to flow back to that device. In the age of 5G, we can cut that latency down materially to either 20 milliseconds or 10 milliseconds. You can imagine that when you get to that level of latency, you can create some truly innovative use cases that allow us to use the network to move workloads at the speed at which the mind processes reality. That is the level of latency that we're talking about. And over the course of the next few minutes, I'm going to take you through some real examples of the sorts of use cases that is going to enable. So let's take a moment and talk about this thing, which is the network edge and the customer edge, and why they matter. So why don't we start with multi-access edge. Multi-access edge is the term that AT&T Business gives to 5G and edge computing that is resident at a given customer's premise. Private 5G, private cellular with edge compute, is another series of terms that individuals in the industry use to describe this set of capabilities. Quite simply, what we do with multi-access edge is we deploy a cellular umbrella at a hospital, at a venue, at a base, and then we give that business the ability to manage the application level traffic at their location, which is pretty incredible, right? If you're an administrator over that building, you can now use the reliability of a cellular infrastructure significantly better than Wi-Fi. You can decide what data you want to keep local on your premise versus route back to the centralized cloud, as well as then, as we said, you can do that for any given application, so you have control over certain applications going back to the cloud versus certain applications staying on-prem. Let me bring this to life for you with some real industry examples. Why don't we start with using healthcare? In any given hospital, you have what you see in front of you, right? You have machines that are being used to capture images of patients. You have doctors and nurses and healthcare practitioners that are working with their patients, as well as then concurrently, you might have a guest that's there to see one of their loved ones, a family member, a friend, etc. You can see that there's a series of small cells that are distributed across the hospital, and then we give the administrator at the hospital the ability to choose what traffic goes back to the centralized cloud versus what traffic is kept at the hospital. As an example, you have an MRI machine, you want to keep that traffic local, so very quickly that MRI image can be sent to the next doctor who's going to be looking at that MRI and making some sort of healthcare decision around it. Concurrently, you have a guest at the bottom of this screen that is sitting waiting to see their loved one and is out streaming their favorite over-the-top entertainment. They're going back to the cloud, and that traffic is being routed appropriately. Highly secure, application-specific, with ultra-low latency and security. An incredible use case. You can see how this will be very useful in a hospital environment. Let's move on to the next example, manufacturing. In this scenario, you have a worker who is using a video as a sensor device to inspect their airplane. That is going over the small cell to the multi-access edge computing device and being routed to local compute that is on-prem. If there is some sort of defect, that information is being routed to an administrator that is monitoring what is happening, and very quickly, within milliseconds, they can identify that that defect has occurred and go in and address it. Concurrently, you have a worker that is on break. They're out on their favorite social networking sites. That application traffic is being routed back to the core. This is the power of MEC. being able in milliseconds to respond to defects while also allowing appropriate traffic to flow back to the World Wide Web. Let me give you another manufacturing example that we have deployed with Samsung Semiconductor in Austin, Texas. In this use case, Samsung is using these capabilities for three things. Near real-time inspection, as something is being created on your manufacturing line, within milliseconds identifying if that thing is aligned with the spec example. Is it perfect? If not, shut down my production line and let me address that very, very quickly, potentially saving thousands, tens of thousands, or even millions of dollars in defect management. Virtual reality training. If you have a facility that has turnover of employees and you're needing to bring in new folks every single year, how can you make them the most efficient employee as quickly as possible? With virtual reality training, you can have your single best trainer train every single new employee. You can also use what we call remote hands capabilities, where if someone gets stuck when they're working on a piece of equipment, they use See What I See video cameras that are built into their AR equipment to phone a friend, let someone virtually see what they're working on, and quickly be able to help them address either an installation or a repair opportunity. And of course, personnel safety, being able to use IoT sensors to very quickly identify potential safety issues, chemicals, things that humans may not even be aware of if they're present, and alert them to that safety issue and route them out of the building as quickly as possible. Let me quickly give you a retail example as well. In this use case, historically, you might have some sort of robotic device that would utilize the Wi-Fi network, potentially overloading it when you're also trying to use Wi-Fi for your guests and other capabilities. With MEC and 5G, you can now move your mission-critical robotics that is doing inventory scanning, looking at your shelves, route that over the multi-access edge compute network, and keep that traffic local, versus your shopper who's on a personal device can continue to be on the internet or hand that device to their kids and distract them so that they can shop in peace. A very, very interesting use case that we've deployed and are working on with real retail customers. Okay, so we've talked about the customer edge and multi-access edge compute. Now let's move on to the network edge. What is the network edge? Well, just as we're in the middle of deploying cloud instances to customer premises, we're also in the middle of an effort of working with cloud providers to bring cloud instances to major metros across America. Simply put, NEC is a distributed public cloud platform embedded in the network edge, synergistically working with both our mobility networks as well as our fiber and wireline networks. When do you use this versus MEC? If you have MEC, why do you need NEC? Well, the answer is, hey, if you've got a large geographic footprint and you have use cases that are outside of an individual business location, well, NEC might be a fantastic use case and opportunity for you to think through moving expensive compute out of your business locations and into these NEC instances. NEC also enables consumer use cases via business to consumer opportunities, businesses that want to bring incredible new capabilities, low latency experiences that then allow them to serve their consumer end customers in a new way. Let me bring this to life for you with a real example. A great use of NEC is for any business that has highly distributed footprint, aka branch locations or multiple locations, franchisee locations, etc. They want a common experience across all of those locations, but they don't necessarily want to invest in compute and applications to sit at each one of those. NEC allows them to shift that expensive compute, utilize someone else's capital investment, and then coupled with our fiber and mobile networks, move that experience into a nearby cloud. Great examples of what you can bring to life with this is reduced operational costs, aka not having to invest in all of that compute at each location, as well as new customer experiences. I think my favorite example of this, highly relevant in a post-COVID world, is the virtual mirror, right? The magic mirror, if you will. large screens, televisions, if you will, with built-in 4K cameras that allow a retailer to enable someone to stand in front of them, treat it like it's a mirror, and try on different combinations of clothing, all without ever needing to go into a changing room. The heavy and expensive compute tied to that can be shifted into a centralized cloud instance. And then, of course, because that cloud is within miles of that branch location, the latency capability of it allows that person to stand and swipe left and swipe right, try on different clothes, and it looks like it's instantaneous to them. An absolutely amazing capability. Another great example that I bring to life for you is drone detection. We're working with a small company outside of Israel and one of the large cloud providers to bring drone detection to life. What is drone detection? Well, drones are incredible tools. They can be used for good, or they can be used in ways that none of us would want them to be used. There's a reason why drones are not allowed over major sporting events, or airports, or other points of interest. Today, there is no great way without visual inspection of knowing if a drone is flying into an area where it's not supposed to be. So what this company does is it uses the NEC capabilities along with other triangulation opportunities to detect when a drone is taking off and is it flying over an area that it should not be. And then it alerts law enforcement who can take the appropriate actions with the drone operator. So what does this mean? This means safer cities with incredible new capabilities and more effective law enforcement. Now, you can imagine the ability to do this is reliant on a highly distributed set of compute, perfect for NEC deployed and coupled with our 5G and IoT capabilities. So let me net this out for you. 5G with edge compute is going to reshape the fabric of our society across the next 10 years. Just like LTE and centralized clouds or regional clouds defined the last 10 years of communication, of entertainment experiences, always on video and audio, applications that redefined how we live our lives with Google Maps and Waze and Airbnb, etc. In that same way, the deployment of 5G networks, along with this shift of cloud instances into both major metros across America, as well as individual business locations across every single industry that you can imagine, is going to create the next set of incredible outcomes, both for enterprises as well as for consumers that are going to enjoy the experiences that the application development ecosystem and innovators and businesses everywhere are going to create. I, for one, cannot wait to see it happen, and MEF will be a key part of bringing this to life. Now, to wrap it up, let me give you one other fun example and how we're using this technology in the lens of entertainment and venues and stadiums. Now, I'm in Dallas, and you can't be in Dallas without being a fan of the Dallas Cowboys, and I'd like to take you through what we have brought to life at AT&T Stadium. Some truly incredible next-gen experiences that fully take advantage of the capabilities that I have been articulating for you. We've launched some truly amazing experiences. This shows you some of my favorite. The Hall of Heroes allows you to interact with one of your favorite players, do a touchdown dance, high-five them, and then capture that experience so that you can share it with your friends, your family, or on social networking. Pose with the Pros is another variant of that magic mirror technology that I articulated. A huge TV screen with built-in cameras. You stand in front of it and you can interact with your favorite players or your favorite cheerleaders. And this has been called the greatest fan experience in the world. You have to see it to believe it. And one of my favorites, VR, AR experiences at the stadium. This comes to life in a couple of different ways. One, you can point a 5G-enabled device at the field and play games where robots are battling your favorite players, or during a game, you can see real-time stats hovering above your favorite players as they're playing. This is bringing the best of the at-home experience coupled with being there in person and all the excitement that comes with it. And you can imagine these sets of capabilities create future opportunities for interacting with fans in new ways, allowing them to pick their favorite camera angle, either at a game or at a concert in the future. This, my friends, is the beginning. This is the beginning of 5G and edge compute and bringing to life the future of fan experiences and engagement, the future of business, and the future of consumer experiences more broadly. I hope that this has given you some background and insight into what we're doing at AT&T Business and how we're thinking about 5G, edge compute, and creating the future. Thank you for your time, and I hope you have a great day.
A journey of 1,000 miles always begins with one step, right? Hey, a big thanks to Mo and AT&T, one of our Tier 1 MEF 3.0 certified providers, for an excellent start and some great insights. But Jeff, what about the vendor side, you ask? Well, we've got that covered too. MEF CTO Pascal Menezes sat down with industry veteran Steve Alexander, SVP and CTO of Ciena, a MEF 3.0 certified technology provider, for a very candid CTO to CTO conversation about their take on faster, closer, and smarter at the edge. Let's listen in.
Well, welcome, Steve, to this great Infinite Edge series on the edge. Real pleasure to have you on. Ciena has been a huge contributor to MEF, especially in the carrier Ethernet standardization. And, you're a rock star, so really, really great to have you here. So, I wanted to talk about the edge and get your thoughts. The edge is coming in so much, really, really fast, and there's so much going on the edge. So I know that Ciena has a position on the edge, and I know you do too. So I'd love to hear your thoughts about you're a believer in networks, being faster, closer, smarter. Can you kind of elaborate on what that means for you and Ciena?
Sure, happy to, Pascal, and thanks so much for the invitation. MEF has been instrumental in bringing, real carrier interoperability and just defining what Ethernet meant for the world from a service provider point of view. So, congratulations to MEF for all that has been done here. You're spot on. When I talk to customers, I talk out to the industry, I almost always end up talking about the network getting faster. I mean, we all know the network's just going to get faster. It has been getting faster for, 3-4 decades now, right? But in addition to faster, and I think this starts to touch on this conversation around the edge, it's bringing the cloud edge closer for a whole bunch of reasons. Latency is the one that people typically think of as being the driver, and we'll talk a little bit about that in a minute. But the other piece is going to be the network has to get smarter, right? And the smartness that's there today is okay. And some of it's been contributed by MEF and all the work that's been done there. But when you look at scale, especially as we're getting into the Internet of Things and we're going from, billions to tens of billions to maybe 100 billion things connected and talking and all this, you need the software intelligence to deal with that kind of scale. So let me just start with the faster one, because I think that's one I think most people associate with Ciena anyway. When I look back historically, and I'll look at the Ethernet world, it took us, I think it was around 35 years to go from, the original, 3 and 10 megabit kind of specs on Ethernet now to what is the high end, which is 400 gigabit Ethernet. But just within the last couple of years, there's been an explosion in terms of the number of Ethernet rates available. A lot of these were created to support, the kind of cell site backhaul, the 25, 50 gig standards, but you've got 2.5, you've got, 25, 50, 100, 200, 400, 800 now is being looked at, 1600, 1.6. And if you look at the continued progression in silicon technology, we're now at 7 nanometer. You go forward to 5 and 3 and 1.x. Where is that going to go? You can start to see data rates in the Ethernet standards well in excess of a terabit. And that's a very high data rate, right? That's what people would have typically associated with core networking speeds. And here we are talking about them being, Ethernet out at the edge of the network. You're going to be a service provider going to a customer and they're going to say, look, I've got a terabit local area network. I need you to interconnect this over distance for me, right? That's a, much higher data rate than we typically think of. So when I look at the network, absolutely, we're going to continue to drive connectivity and capacity out to that edge. I mean, that's what Ciena has been doing, for 20 something years now, right? We're big fans in making capacity and connectivity just abundant, right? We think a lot of good comes from that. The closer piece speaks to this cloud edge. We look at the kind of experience that we all want to have that's cloud enabled, this immersive AR, VR kind of world. We want the gaming experience. We want, be able to control, close control loops on the factory floor. And I've started to talk to people from kind of the physics point of view, because there's lots of definitions of what the edge is and where it could be and such. What I've started talking in terms of mean time to cloud, right? From whatever is at the edge of the network, whatever smart device you've got, a robot, a display, a camera, whatever smart, intelligent thing sits out at the edge, there's going to be a requirement to get the right experience that you want. If you're doing really immersive gaming, there's numbers around 10 milliseconds or so that people are looking at to saying, if I can get, round trip latency to the cloud and back in 10 milliseconds or less, I won't get anybody with any kind of motion sickness. There's a couple carriers. I know, there's been some publicity around a 5 millisecond spec that people have talked about. I talked to someone just last week over in the Middle East with a 3 millisecond spec. Well, and you look at, how metro networks were built over the years, 10 milliseconds on fiber, that's 1,000 kilometers. It's 5 milliseconds out, 5 milliseconds back. It's not propagation on fiber that's setting all these latencies. Because when you measure latency in most networks today, you're going to get numbers that are like 10, 20, 30, 40, 50, sometimes 100 milliseconds. All that latency buildup comes from the number of times we go up and down a stack, the number of times we go through OEO conversions, all the other things we've built into these networks to aggregate traffic together, to steer it, to just put all the traffic together, to converge a wireless infrastructure with a wireline infrastructure, to bring in what was effectively the old enterprise business and the residential business and the wireless business, maybe as 3 different networks, and converge them someplace in the core. Coming in and out of all of that and going off to some public peering location before I get to the cloud, that all introduces a tremendous amount of latency. So what we've seen people doing is overbuilding, right? And you see this with the cloud operators today, the web scalers. They basically are locating their first cloud presence closer and closer to their users, and they're pulling traffic effectively out of the service provider infrastructure, getting it over to their infrastructure, because then they can control the user experience, right? So that whole cloud edge is coming closer under this kind of mean time to cloud model that I talked about. The last one is smarter, right? That's all about the scale. And when you look at what has to happen, right, what you really want is what I would call a converged user experience. You want the same experience whether I'm in the building or outside of the building. Today, those are typically different domains. Frequently, I'm in a building, I'm a commercial building, it's an IT shop that owns it. If I go outside, well, it's a service provider. If I'm at my house, it's my local Wi-Fi, maybe on one service provider. I walk outside, it's another service provider potentially. Getting a consistent user experience across all those, that is the software intelligence that's needed to give us the ability to have kind of this ubiquitous experience. So inevitably, when I talk about the edge and where a network's going, it's faster, it's the cloud edge coming closer, and it's all about smarter.
Yeah, no, you hit it right on, actually. I think it's spot on. And I think the smarter part is really, really also critical. With all that inference being done very close to the edge, with robots needing, AI and neural networks and the IoT processing done locally and, closed loop automation. I know you're doing a ton of stuff there, and you're, you really have put together a great portfolio, from the transport to the software, your Blue Planet portfolio, and now all the intelligence for the analytics, just brilliant. So yeah, I totally agree with you. So look, there was I'd love to hear your thoughts on the importance of, the network and edge computing. I think in education is a really cool area. So especially, learning from home environments. So, Could you have any thoughts on that? That'd be really, really great to hear your thoughts.
Oh, yeah, because, I think, we've all seen and had different experiences with kind of the learn from home environment that we're in because of COVID. But I think it's created a lot of opportunity. And I think we've just really scratched the surface of where education can go, because done correctly, if we can get the right, edge computing capability close to the students, get the right content loaded there, all of a sudden you now start to have the ability to almost learn anything, anytime, anywhere. It starts to talk about breaking down some of these, artificial barriers, the digital divide. Of course, the students got to have the smart device, the thing that will interact with the cloud and bring the content down. But we're just at the beginnings of this. I mean, you can imagine a world as we get these AR, VR kind of capabilities established, where if you're in high school and you want to understand, well, what's it like to be, in physics or engineering or medicine or construction or architecture or painting or music, or just pick it. You put on the headset and you experience that for a period of time. It's kind of like, walk in the other person's shoes and understand what's it like to have that kind of a job and just experience it. So I view it as we're just now scratching the surface. There's huge opportunity in what we can turn the educational experience into because of the proliferation of the cloud, and in particular the edge cloud.
Yeah, I think it'd be, so amazing that people could work from their homes or, learn from their homes, as you discussed, and put an AR, VR headset or extended reality headset, and you literally see the classroom experience and where people are, and get all that, inference, and the names show up on their heads, or I don't know. There's so many great things.
No. You're absolutely right. We've even with our IT department has started putting headsets on folks who have to go do remote provisioning, or if they aren't fully trained on a particular piece of networking gear, be able to put a headset on and then have a remote expert, kind of take you through it. I think it's very much like odds are what many of us do. If you got to go, I don't know, fix something on your car, or, how to change the light bulb in your refrigerator, or anything like that. A lot of times, what do? You start with YouTube. You say, oh, somebody's had to do this before. I'm going to watch what they did, and, I'm going to learn from them. Well, imagine if you had that kind of expert capability for almost, anything that you could think of needing to do. You put the headset on, and all of a sudden you've got the world's experts. You've got this instant masterclass that just happens right in front of you, and you get all the additional information. And you can take that kind of environment. We talked about the education world. You can apply it to, sports. You can apply it to just all sorts of, fields of interest. It's that ability to deliver, rich amounts of information to people in a seamless manner. That's what I really think is in front of us here. And that's, again, all driven from the ability to connect people to the edge and the edge to the cloud.
Yeah, no, absolutely brilliant. And, today you go and try to commute anywhere. It can take hours going back and forth, and people living further away. So I just think, there are a lot of great benefits from what COVID has enabled us to think through and allow people to work from home. And certainly education is also one of them. Getting on to the topic of edge compute, we've talked a lot about the value, the benefits, the opportunity. But I'd love to hear, what do you think of the challenges? Edge compute is all nascent. It's the buzz and so many potentials possible, but I'm sure there's challenges. I'd love to hear.
Oh, there are. As you pointed out, it's nascent still, right? There's some really good examples of it, but it isn't particularly widespread. And the Earth's a big place, right? Moving from 4G to 5G, the densification that's required on antennas, the other places that you're going to have, access to the network. We still have a tremendous amount of the world underserved, right? That's the digital divide that we're, have kind of mentioned earlier. So there's lots of challenges. It starts with, availability of, real estate. Can I put a data center there? Do I have connectivity at that site? There's administrative boundaries. How hard is it to put, a compute capability at a certain location? The permitting process, the building process. There's all sorts of things that go into that. Once it's established, even existing carriers, going from, kind of a large metro central office out to the edge, you may cross 2, 3, 4 administrative boundaries with different people with different keys and combinations and understandings of who owns it and different budgets, and all sorts of things occur when you come from, the core of the network out to someone's, residence or, to their enterprise, right? And dealing with all that kind of complexity, it can be somewhat daunting. That's why it's so interesting to watch some of the first movers. How do they approach these problems? There's a lot of variation across the world. What is done in North America is different than what can be done in, Europe, and what can be done in India and China and Japan. They're all different in some sense. So it does have a myriad of challenges out there, but you think of the benefits of being able to go to someone and say, here's a device and it can connect you to all this computational power and all of this content and information and intelligence that's all basically, quote, in the palm of your hand. I mean, that's where we're moving to. But you're absolutely right. There are going to be challenges in all sorts of directions here.
Yeah, you nailed it right there. I think, it's funny how we see all this technology innovation, but a lot of times people get in the way, processes, bureaucracy, and so on. So,
well, and I'll go back to, I think, you mentioned earlier things like Blue Planet and our investments in software and, the adaptive network kind of concepts that we put out there. I'll go and the soundbite that I think kind of captures this the best is, you look historically at our industry, the telecom industry and such, and you say, what's the best example of taking something that is hugely complicated but applying software intelligence to it? And I'll go back and look, I remember, the flip phone, the feature phone, okay? And, you would open it up and you'd get an instruction manual that was, probably a centimeter thick. And you and I would page through it, and in 5 or 10 minutes, you and I could figure out how to put each other on speed dial, right? But that was the state of the art at the time. You've now got a device, the smartphone, 10,000 times more complicated. It can see what you can see. It's got a camera. It can hear what you can hear. It's got a microphone. It can tell you where you are in the world. It carries your calendar. It carries all sorts of stuff are all contained in this. And there's no manual, right? You can take this device and hand it to a 6 or 7-year-old, and you're going to kind of figure out how to use it. And that's because so much attention was paid to the software intelligence that made it usable. Right. And I believe the same thing has to happen in kind of the networking space. You have to get the software intelligence in place so that the network, the whole infrastructure is just kind of like air. It's just there. We just use it. I think we all saw this with COVID, right? You could get the cloud app, you could get Teams, or you could get Zoom, or you could get WebEx, whatever you want to download it running on your PC in a couple minutes. Boy, if you didn't have a network connection and you had to go order that could take days to weeks to months, right? It's getting the network to catch up with the speed of the cloud in many cases is what, edge compute and connectivity is all about.
Well, one of the series and episodes, someone said networking is cool. It
is.
I love it. Networking is cool again.
Yeah, it's what connects the world, right? So it's
what connects the world, and everyone thinks it's plumbing, but it's not plumbing. It's very sophisticated. It's very elegant. And more importantly, now it's cool.
Oh, yeah. And you know what happens when your plumbing doesn't work? It's a bad day.
Absolutely. Well, Steve, it's always a pleasure talking to you. And again, we're very grateful for Ciena's contribution to MEF.
Thanks, Pascal.
And really, thanks for being part of this great episode.
Sure. And happy to help. I think MEF's done wonderful things for getting Ethernet out there and getting it consistent across the world. So congratulations.
Okay. Well, thank you, and keep well. Take care.
Thank you.
Gentlemen, thank you for a great interview from start to finish. I know our audience appreciated hearing Ciena's position on the edge. Now that we've gotten the service provider and vendor perspective, pushing the edge with our esteemed analysts seems like a natural next step. So here to dissect the edge computing market for us are David Strauss of Broadband Success Partners and Ian Redpath of Omdia. Gentlemen, over to you.
Hello, Ian Redpath here from Omdia, and I'm with David Strauss from Broadband Success Partners. David, how are you doing today?
Terrific. Great to be here, Ian.
Well, we're here today to talk about edge compute. And edge compute has really captured the industry's imagination. All the industry actors are involved, from the communication service provider community, the cloud and SaaS provider community, major data center operators, and even some startups are in the game. So edge compute will encompass many types of ecosystems, from software and application environments, orchestration for not only bandwidth, but also compute. It will involve the compute itself, bare metal, general purpose CPU, GPUs, and edge compute will even be a real estate play, and topics such as carbon neutral power generation will come up as well. And of course, for the bandwidth community, we expect major change and major growth from low latency fan-in bandwidth coming from the enterprise side and the computer side, and also more growth on the, what I like to call the terabit data center interconnect core. So traction has already begun from some of the major CSPs, and even startups are already in the game. So my first question for you, David, is you've already conducted some insightful market research into the edge compute marketplace. Could you share a little bit with us and help us frame it up from the perspective of definitions and locations?
Sure, Ian. Thanks for that question. We interviewed about 24 cable executives, tier 1 and tier 2 in North America. And regarding the definition of edge compute, it really was fairly split in that, 44% of those defined it as transforming head ends and hub sites to mini data centers, otherwise known as HERD, or head end re-architected as a data center. Next up, 30% viewed it as distributed compute and virtualization via DAA, or what we know as distributed access architecture, and or flexible MAC architecture, or FMA. And almost as many executives, close to that 30%, noted that they need to build new edge sites. And our view as to why the answer is varied as they did was really probably the mindset the interviewee, the executive, was in when we asked the question. If they were thinking about an application where that required, ultra low latency, such as autonomous vehicles or AR, VR, for example, then they were in the headset of a more distributed architecture, and thus having edge even closer, if you will, or the edge compute even closer to the end user. However, if they were thinking of things such as video caching or SD-WAN, perhaps a less distributed architecture, and thus answered that question differently. As far as the locations are concerned, it was really a split between head ends and hub sites as being the primary locations that were picked. And we asked this question as to why you picked the answer you did. And this one answer really encapsulates what many of the executives had to say or were thinking. It really depends on the tipping point of the finances of, or the investment in edge compute versus the actual tolerance for latency. So it's really optimizing between those two factors as to where they believe the hardware needed to be. So, Ian, a question for you. What are the key drivers for MEC under discussion in the industry today?
Yeah, thank you, David. Well, I think the key enabler, and you touched on it already, is absolutely low latency. I mean, the purpose of edge compute is to shift the data and the decisions closer to the users and the devices to enable that superior user experience. So, moving to low latency is absolute paramount. The big driver, of course, is the big driver that we always have in this sector, and that's revenue. So it's the combination of revenues that we see today and revenues that have yet to be defined for future applications that have not yet been envisioned yet. So that's really the big prize, is getting a larger slice of digital economy revenues enabled by low latency. And that's also important to keep in mind that, there's a lot invested in terms of protecting today's revenue. Today in the gaming environment, in the video delivery environment, users have really heightened expectations around performance, and they're very, very sensitive to it. And so if they get, the sense that one network will perform better than another, they'll move very, very quickly. So there's a lot of a revenue protection aspect involved here as well. And then there are other drivers, beyond that. I mean, drivers in terms of, rapidly being able to scale operational and capital efficiencies. So it really encompasses the entire ROI for the carrier community. So David, back to you. From your perspective, what are some of the really intriguing use cases that have been bubbling up from your perspective?
Thanks, Ian. Well, video caching is fairly widespread with, over the top and streaming and so on. So when we asked this question, we said, given that that's already pretty pervasive, what are the next use cases you're anticipating to really drive service providers to go further toward the edge? And not a surprise, cloud gaming is that primary edge use case. And as we well know, given the circumstances associated with COVID-19 and the lockdown, video gaming has really accelerated at a hyper pace, if you will. And thus, that's a use case that's accelerating the need for edge compute. Next up, healthcare and sensors, massive IoT. That also popped near the top, if you will, as a use case. And equally popular was surveillance and physical security. So next up, question for you, Ian. Carrier monetization is a central and key topic in this area. What are your thoughts on carrier monetization?
Yeah, thank you, David. And yes, it is really back to the whole ROI. So, for the carrier community, the investment ask on edge compute will just continue to expand over time. I mean, today's edge compute sites from the major CSPs are relatively defined and contained. Tomorrow's are going to be more numerous and diverse. Today's sites, a little bit, we're talking in terms of edge, but the grand scheme of things, they're a little bit more centralized. They can be staffed. Tomorrow's are likely to be much more distributed, remote, and very likely, unstaffed or occasionally staffed. So their costs are going to rise, and real estate costs will rise, and the big concern is OpEx costs rising. So when I look at some of the revenues that are being talked about today, they're all very well and good. Of course, space, power, things like remote hands, potentially bare metal, premium bandwidth. So these revenues to be sure, but to me, the real idea would be to get a slice of that true digital economy top line. If they could tap into those revenue streams more directly, then it will just make the entire case a lot more appealing. And then that could flow, back into the CapEx cycle, and a virtuous circle can be set up. I think the way forward there is likely more of a partnership model and a partnership mindset. And one angle that may be a path forward is really around the mission critical and the cannot fail. Like we do talk about consumer types of services. Those are all well and good and will drive revenue and then in turn drive investment. But think about services that are the criticality is taking up a whole level. And in that environment, I think the CSPs will have more leverage, to set the terms and, tap into that digital economy revenue uplift. So, monetization is absolutely central to the whole discussion. So kind of throwing it back to you, we've talked a little bit about monetization. What are some of the other challenges that are key in the whole edge compute market development from your perspective?
Thanks, Ian. Well, just to confirm, as you noted, monetization is in fact key. And when we asked these executives, the 24 executives, what challenges were greatest, the number one had to do with monetization, as it so happens. 42% noted that having the operations in place to supporting monetization of new service and business models was in fact the greatest challenge, though after that, adaptability came in at about a quarter of the executives citing that as a key challenge, meaning knowing when and where to adjust and adapt network resources. On the heels of that, at 17%, was what was known as resources to support and manage the edge compute facilities. And then next after that was actual performance, delivering the low latency requirements of edge compute. So that's sort of the landscape, if you will, as to the challenges that these executives are experiencing and plan to experience, in the near future as they move in a faster pace toward edge compute. So next up, let me ask about, from your vantage point, what are you seeing, Ian, vis-a-vis the timing with regards to the speed with which the players are getting into the game?
Yeah, thank you, David. Well, this is a really interesting question, and I think the answer really depends on who you're asking and their perspective and their lens already. So we've talked about some of the major tier ones that are already into the dozens. I think rapidly getting to hundreds of sites. If you talk about some of the other industry actors, I mean, they're going to give you a completely different answer. I mean, if you went to an Acabai and you mentioned the CDN world, I mean, I really like the way that they put edge compute. They like to cite the CDN, their CDN business is the first revenue generating edge compute use case. And the Akamai network is well over 4,000 sites. So a significant network has already been in place and in place for many years. And then if you maybe take a look at a company such as Rakuten, and listen to the way they're building out their radio network, utilizing the cloud. I mean, they're talking about targeting 10,000 sites in their own domestic market. So, we've had some different numbers out there, and it kind of depends on the timing as well. So the way I like to look at it is that the far edge market development is really a multivariate business and network planning challenge, and it will take time to really scale out. One of the interesting numbers that we've been hearing in a European context is potentially getting to tens of thousands of far edge micro type sites, for a European country economy. So, bringing this all back to bandwidth, this is going to drive a lot of growth and a lot of change. And, just summarizing from the perspective of our bandwidth community, as we mentioned in the beginning, we expect enterprise and fan-in bandwidth. So all the types of bandwidth that we know and love today. We could see enterprises coming in at modest levels, the 50 meg, 200 meg, the gig and whatnot. But we expect that to absolutely grow and scale. And then on the core side, really when we're looking at some of these larger edge compute sites, I'm thinking in terms of 100 gig and 100 gig for each physical fiber route that's at a facility, and that's just the beginning. That's the starting point. 100 gig for each route, and it just grows from there. So we are talking about a tremendous amount of bandwidth. So on behalf of David and myself, thank you very much for listening.
Thanks, Ian.
Thank you, David.
David and Ian, thank you so much for adding to today's conversation and providing a broader context for our discussion. I'm sure our audience appreciated your keen analysis of the market. Now, to accelerate our conversation this morning, let's switch gears to discuss MEF's projects on edge computing and the relationship to MEF's current activities in orchestrated carrier Ethernet, SD-WAN, and SASE. For that, MEF CTO Pascal Menezes joins us once again.
Hello, everyone, and welcome to today's episodes of The Edge. What a great topic. Such great innovations happening here at The Edge, and edge computing is going to drive digital transformation to all kinds of new use cases. So let's just get started right away. Number one, as you know, with the advancements of the edge computing, we're going to see all kinds of new low latency applications, specifically around 5G. The ability of 5G to enable that edge is huge. And stay tuned for that. And the next episode will be coming a lot in 5G. So I won't spend a ton of time. But basically, number one, I think a very big area is the idea of smart glasses are going to emerge. And what you're going to get a glimpse of is in the future, the next 5 years, that edge is going to play a very, very critical role for the usage and the use cases around smart glasses. That's extended reality. And you're going to see there are already chipsets coming out in this area. There's already a lot of innovation. And as we know it, the mobile device will move away into smart glasses that you put on regular glasses that will have both augmented reality, virtual reality, all kinds of innovations. As you turn, look, the edge is interacting with you with all that compute as to what's going on and what you're looking at and all that inference. So these are very, very important areas. Another area that's growing a big growth about the edge is IoT and specifically surveillance. Surveillance is playing a very, very critical role because massive amount of bandwidth are going to be streaming from all these video surveillance cameras. And at the edge, they're going to be taking these surveillance and doing video analytics and processing that and deciding what to do with all that information. So another great use case that's driving the edge and a reason for having analytics at the edge. Also, we're seeing smart manufacturing emerging. It's really projected to be close to a $3.94 trillion economy itself. Robots and manufacturing have to be driven by AI ML, and that's going to need AI ML at the edge. So really, really critical use case also. Another area that's driving the edge is really cloud native microservices applications. And these are distributed applications built with microservice components. And they really have a service mesh connected to them that is a sidecar in the containers and the pods of all these microservice applications. And that's going to drive the need also for the edge itself to have this platform for a distributed computing environment, a distributed cloud in a way, and very, very powerful innovation that's emerging in this area. So really, what is MEF working in at this edge? As I said before in previous episodes, we've been covering this underlay, and I'll recap it in a second here, showing you how the edge plays in this underlay and this automated high-speed fabric underlay. We've been talking about this very agile, programmable, policy-driven application where overlay SD-WAN. We're doing a lot of work in MEF in that area. We're also doing a ton of work in this managed security area, specifically managed network security around SASE, is a very hot topic. Zero trust we're working on, and we're planning to expand onto XDR. So that's going to be a very important area. So these are really critical roles. But today I'm going to talk specifically about what is MEF doing at the edge, and the edge is absolutely very critical for digital transformation. So let's just get in the details. What exactly is MEF doing at the edge, and why is it so important that we get this right? And it's important that we, network transformation is the underpinning for digital transformation. And I've said this many times. And at MEF, we are really addressing this underpinning network transformation, and the edge plays a critical role. So let's just get into all the great things we're doing at the edge. Number one, as you can see, we've been working on these commercial automated APIs between providers. I talked about this in the past. We have today in the ecosystem, many service providers around the globe connected at their data plane, connected with their networks at the 10 gigabits to 400 gigabits to 800 gigabits emerging. And this very high-speed fabric, global fabric, is interconnected at massive rates, unlike the internet. And this is the foundational backbone of all these providers connected together that then enables these edges, no matter what part of the globe to the other part of the globe, to be connected with this high-speed fabric, then to overlay on top of that all those SD-WAN overlay services. And what we're doing at MEF is to enable that edge, not only for automation from that edge, in the way of turning up that underlay services at those edges to all those various local loops, whether it be carrier Ethernet today, IP broadband DIA, IP MPLS, 5G, fixed wireless access. All those underlay loops really have to be turned up. But what you're really seeing the trend is basically that instead of using the internet as a backbone for overlaying, we're seeing that the edge is where you bring in all these accesses from all these different access loop technologies, put an SD-WAN overlay and get to the edge right there with edge computing, and then hit the SASE cloud. And then from there, wherever it needs to go, it uses this very high-speed backbone of managed networks that's being invested from all these service providers for decades, and cloud providers that have direct connections at 10 to 400 to 800 gig rates like I talk about. And this is the critical aspects from edge to edge, anywhere in the world using a very high-speed fabric. And at MEF, we've been doing all that commercial innovation to really allow that automation capabilities of these edges to talk really both at the access layer and the local loop layer and between these providers. Another critical area that we're doing at the edge also is this idea of facing the enterprise. More and more we're seeing the need that these enterprise want automation APIs, especially these multinationals, big, large corporations, want automation APIs so that they can talk to the edge or the nearest edge even, find the nearest edge for nearest address location, ask what is the edge that's capable of compute resources, APIs, and so on, and then basically look for a price quote and then order that and then instantiate all its needs of operational services. So things like what we've been working on is all of this is taking that Sonata APIs that we've been doing into providing and now taking all that API work of commercial APIs and facing the enterprise now so they can buy, get quotes, order for anything, not just carry Ethernet or IP broadband, but SD-WAN and SASE, but also edge computing is a very important area. Maybe they want voice services, maybe they want a bitstream kind of services, and who knows what else they want, AI services and so on. And all of that, they want to be able to automate and order that from their edge. So at MEF, stay tuned, we'll be releasing our first Cantata release in our upcoming SDK release called Billy in May that will have all the work and innovation we've done with Sonata APIs put into Cantata facing the enterprise for that commercial aspect. Additionally, we're saying enterprises need and require the ability that once they get and they've ordered their edge compute and what they need and to access the SD-WAN and the SASE environments and so on and their clouds, they also want to maybe instantiate, put software bits into that edge on their own, and that needs a lifecycle service capabilities of that edge. They also will want to maybe call in APIs of platform as a service, or serverless computing, function as a service. All of these needs are going to be delivered from the edge, and this is very, very critical. And so here at MEF, we're now working on the commercial aspects, as you see with Cantata, but we're also working with Allegro and looking about how we'll enable Allegro APIs, which are the operational aspects after the commercial aspects of that automation is done. So that's kind of the two major areas we're working on in automation for the edge. But let me continue more about what we are doing at the edge in the way of end-to-end slicing and how that ties into 5G. Obviously, the edge will be enabled with 5G fixed wireless access from the public side, but there's a ton of innovation happening with private 5G. And why is private 5G so important? It's really, really this simple. At the enterprise sites, and especially industrial sites where robots are involved or robotics, or very, very mission critical IoT devices that have to do with manufacturing or industrial processes, they are very, very critical for real-time processing. And at those edges, basically wireless is going to be used, specifically 5G, to give deterministic airtime, fairness, and guarantees. And as you know, slicing is a very, very great technology innovation on 5G, and that will also be enabled at the edge, at these enterprise sites, at these industrial sites, manufacturing sites. And with that 5G, these devices will have 5G interface cards attached to them, whether it be, as you see, robots, or it could be, real-time collaboration systems. It could be even all these IoT kind of devices like environmental devices and so on. But all of these will want to attach to the 5G, private 5G in that space, get a slice that guarantees the performance objectives, and then hit the nearest edge at that site, whether it be even at an industrial site or an office and so on. And at that edge, SD-WAN will play a critical role, And then from there, that SD-WAN will take that and map that into a set of overlay policies and then get across the wide area network. And then you'll see this idea of SD-WAN playing very, very critical role of private 5G with slicing in that private 5G. So this is a very, very important role. Now, MEF is taking this one step further. We're not only taking the slicing that's really designed for 5G, but we're really applying it for end-to-end slicing. Now, if you have not seen, I encourage you to go to our MEF proof of concepts, and you'll see a lot of great proof of concepts that have been demoed, and it's on demand. You can go see it anytime, and you'll see a lot of end-to-end use case of these end-to-end slicing use cases on the and a very critical role of that is really how do you enable the slice at the enterprise level or the industrial level to then continue to be used all the way throughout into the transport layers, even in the 5G core and beyond, into other ecosystem providers. And what you're seeing is that slice is being used by the endpoints to attach to it. And then it's when it hits an SD-WAN edge, the SD-WAN edge puts an overlay on top of that end-to-end slice, treating that end-to-end slice like an underlay. And then additionally, that SD-WAN edge could also then put an overlay across the internet for a backup or offload on non-mission critical application directly right onto the internet and not use that end-to-end slice and only reserve that for line of business applications. So, very, very great use cases. At MEF, we're defining not only the end-to-end slice framework and architecture, but we're also defining basically the end-to-end slice profiles. And these profiles are based and built upon the 3GPP, the GSMA, the IETF work. But at MEF, we've defined this as an end-to-end slice profile with specific performance objectives and in the future, maybe even security objectives. And this will be very, very powerful. So with that, we're also working on another big innovation I'm currently incubating, and I hope you agree and join in, is this need for not only having the ability to look at SD-WAN and from the enterprise the user network interface demarcation point, but also more and more enterprises want service providers to manage the LAN environment or the branch environment or home environment and look at that end-to-end view so that it's not just a user to network interface to the actual service, but it's really from the device interface point all the way to the service. So now more and more enterprises want, especially the small to medium enterprises, but now even the larger enterprises are asking for managed services in the LAN, in the branch, and so on. So we're now looking at how can we extend all the work we've done in MEF around SD-WAN and then enable specifically SD-LAN and SD-branch, SD-home, all these scenarios. And this is very, very critical. And top of mind is really in these branches, in these LANs, is not only managing the Wi-Fi or the private 5G, very critical, turning up the slices, managing the radio access, and so on, but it's also very critical that there's a lot of these IoT devices, and they will have to be managed and secure because these IoT devices are inherently can have security vulnerabilities. And you're in our new up-and-coming MEF 70.1 SD-WAN specification at that site edge, we'll have these idea of zones, and there at these zones, we'll have security zones that will push these IoT devices and fingerprint these IoT devices into the right security zone, the right posture. And then also, as I talked about, these zones could be to act as a classification engines for defining from that device what slice they were on for performance, and then handle that on the wide area front with these overlay SD-WAN overlays for performance objectives of the application. And then with a SASE cloud, they can also be currently future-wise mapped into the right SASE security postures in the security cloud at the edge. So the edge is incredible innovation. I want to thank you for joining. Please get involved. We're doing a ton of work of underlays, overlays, managed security, and now at edge services. So take care and have a great day.
Thanks, Pascal. As edge computing proliferates to various sites closer to users, machines, and applications, pivoting to a discussion on MEF's work in that area was very timely indeed. And a very nice finish to the first part of the show. Now it's time to pull this car over, so let's take a few minutes to grab some refreshments and meet right back here for a deep dive session featuring experts from Bell Canada, Equinix, and Exedion, discussing the path from the user to the edge. All right, everybody, I'm out of here. Ah! I said I wasn't going to do that silly towel trick again. No, what are you doing? No, stay on the camera one. Camera one. Oh.
Digital transformation. Massive boost in network capacity, scale, resilience, and performance. Transforming industries, enabling new, innovative applications and business solutions. MEF 3.0 services are critical enablers of this transformation. Service providers rely heavily on robust, standard MEF underlay services, including carrier Ethernet, optical, and IP. When enabled by MEF LSO APIs, they dynamically support the delivery of overlay services including SD-WAN and digital services such as SASE and Zero Trust Security, all coming together at the rapidly changing network edge to deliver a frictionless experience from enterprise to cloud. Supporting the adoption of MEF standards are MEF certifications for service providers, technology providers, and industry professionals. Widely recognized and respected credentials.
It's definitely accelerated a lot of different aspects of our business. The bigger initiatives around digital transformation, cloud, mobile first, and SD-WAN really picked up steam.
I cannot overstate the importance of the certification. And MEF has a huge role to play in this. It has taken a much more difficult task and made it simple.
MEF 3.0 certification enables service and technology providers to demonstrate conformity with the industry's highest service standards. Certified technology suppliers can accelerate onboarding into service provider and enterprise networks, getting to revenue faster. Service providers improve their competitive positioning with business customers by using common terminologies, reducing feature confusion, and demonstrating compliance to critical service functions.
We see a real value in bringing this type of certification to our customers, and I'd encourage everybody in our ecosystem, every provider, to actually pursue this effort.
Building and scaling networks for digital transformation requires a myriad of contemporary skills. MEF certification for professionals defines and validates the expertise required to deliver revenue-generating services central to this requirement. Individuals with these skills are uniquely positioned for career growth and advancement. MEF certifies professionals for services including SD-WAN and carrier Ethernet, with SASE on the horizon.
Okay, everyone, as promised, we've taken things up a notch today with our discussion on edge computing and its frictionless, high-performance, low-latency experience for applications in cloud environments. We made the climb, but now it's time for a deep dive. And our first group of experts tackle the topic of just how industry players are supporting emerging digital applications as compute capabilities are deployed closer to end users. Joining us for a closer look at the underbelly of edge computing are JP Savage, National Director, Network Practice at Bell Canada, Rodney Elder, Global Principal at Equinix, and Greg Spear, Director, Solutions Enablement at Exedian. JP, Rodney, Greg, a big welcome to all of you and a big thank you for being a part of the MEF Infinite Edge series and for being a part of today's deep dive. So let's start off with introductions. If you'd be so kind, share a little bit about yourself and your role within your organization. Let's go JP, Greg, then Rodney, please. JP, take it away.
So JP Savage, so I'm part of Bell Canada, and I do look after our networking practice, so I look after the network portfolio for Bell.
I'm Greg Spear. I'm a Director of Global Strategies and Solutions at Exedian, and my work involves a knowledge transfer, making sure folks know what's going on in the industry, and also working on the solutions with our customers to make sure the right solution is delivered.
Hi, Jeff. Rod Elder. I'm a Global Principal at Equinix. That means I'm in the Solutions Architecture team. But additionally, one of the things I'm working with is the Evolving Edge team at Equinix, and we're focused on all things that are edge-related from a physical perspective, as well as 5G and edge-oriented compute things.
Wonderful. Thank you, gentlemen. All right, JP, let's start off with you here. So why do we need MEC, and in what cases is it useful to move applications closer to the customer?
Jeff, thanks for the question. So from my point of view, I do believe that MEC demand is triggered by new customer experience like AR, VR, gaming, connected cars, and maybe some other enterprise use cases like smart manufacturing and healthcare. And these new experiences are pretty data rich, and they do require some, great responsiveness. So And I think in many cases, the existing architecture don't really provide the latency required to provide the right experience. And so having MEC site that is closer to the end user, that can host the application, it's actually kind of a solution to provide the right performance. So for users on sites that are located far away from the application host site, either the cloud site or the private data centers, latency can really be a deal breaker. So the MEC is going to be particularly useful, for those remote area. So when we think about the 5G, I heard my peers, talk about 5G here. So the 5G use cases being developed, and bringing new services in the market, I think there will be great benefit of keeping the data local to a region. So if I look at my own country in Canada, it's a pretty large, country, and there's going to be great benefit to keep the data local, and that will positively impact the performance of the environment. And lastly, so we typically, associate MEC to 5G, but I do believe there's a number of non-mobile use cases that organization will definitely see benefit, from MEC.
Great. So do you believe that MEC opens the door for new use cases or really improves or addresses existing ones?
Actually, good question. I think it's actually going to be both. So both new use cases and existing, application that you can improve using MEC. Actually, I think we're going to, probably the first use cases that we're going to see is going to be improving existing application, where the organization do have some limitation with the existing deployment or some challenges with the existing support model. I do believe the existing application are probably the low-hanging fruit for a lot of the organization. And that will probably trigger the need for what I would define the public MEC. So really the partnership between the hyperscalers and the service providers. And that will also provide an easy transition to cloud for existing application. And that, MEC solution will definitely, improve performance for the end user. The proof of value is going to be easier to do as well for the organization. There's going to be less investment, and TCO probably easier to build overall. And other benefit is if there's a revenue stream associated to the application, the organization will be able to secure that and make it even better for the end user. So for the new use cases, especially the one around 5G and MEC, there would be for sure more investment and more time spent, to put them in market, a bit more risk. So some of them also have dependency on technology availability or 5G spectrum availability. So there might be a bit of delay associated to those. But don't get me wrong, use cases are very interesting. There's a lot of talks in the market around those. So and they do represent new revenue stream for the organization. So quite appealing, brand new categories in many cases, and some of them will generate actually efficiency and cost reduction for the organization. So in short, I think both existing use case and new use case are as important.
Got it. Thank you so much, JP.
I think.
All right, Greg, coming to you now.
Yeah, I just want to say one thing. What
please.
JP was talking about is the language that we're seeing today when it comes to MEC and 5G and so forth. We hear the word use case before anything else. So it's really about the user, the use case, and then the technology, as opposed to how it was in the past. Just want to add that in. Thanks.
Yeah, great point. Great point. So Greg, why will traditional human interpretation of PM data not work for the next generation networks?
Well, I've worked in telecom for many years. I started when it was X25 and so forth, and the amount of, and for listening to JP, the amount of services, the amount of slices, the MEC, so having things closer to the edge, so there's more compute, there's more things to look at, and having a human trying to manage all this information. So an end user experience, right? You're using your application, you're having a good time or whatever, goes slow. If something starts to not go well, there's so many components involved in your user experience today that it's very difficult for humans to be able to react and manage quickly. So that's where I think the efficiency of monitoring these new and next generation or even current generation networks requires automation to be in the back of our minds as we're building things, because we need machines that are going to be able to go back and take a look at this and say, this is where our area of problem, this is where we need to invest resources, this is where we need to add compute, instead of trying to have a room full of people trying to figure this out. We still need the people.
You mentioned applications. Yeah.
Sorry, go ahead, Jeff.
You mentioned applications. Many applications assume L2 and L3 connectivity is reliable. How can we close that gap there?
And that's where it comes down to, I don't want to get too, in the weeds or whatever, but it comes down to having instrumentation that is deployable in today's network, right? When we think of the guy showing up with his big boots and a test set, we can't do that anymore. We have to have agile. We have to have, agents, software agents that can be deployed by orchestrators that can instrument networks automatically. So that's where the application level, my server response time, my user experience, the component of the network also needs to be validated as we're looking at that as well.
Rodney, headed over to you now. Can you give us an example of a cloud-native multi-domain orchestration task solution?
Yeah, actually here at Equinix, we're experiencing a couple of them. And they range because they have different focal areas. And one of the other things I wanted to bring up, and actually wanted to pick up on a couple of things that Greg and JP talked about, right, around MEC and around the ability to look at this, the PM data, and where do you do these multi-domain orchestration platforms? And at Equinix, with our metal, at our Metro Edge, something we call the Metro Edge, wherever we've got our IBXs, we're finding that a lot of innovative organizations, maybe historically full stack software companies that would sell software as a license are moving to as a service or a platform as a service. And doing that at Equinix on Equinix Metal actually helps enable some of these other things like Greg was talking about, PM management, be able to make decisions about where to steer traffic from an SD-WAN over to a private connectivity. Really getting into like the MEC use case where JP just talked about 5G. MEC, we always talk about MEC with 5G, but the reality of it is that MEC, from our perspective on a metro edge point of view, has wide applicability. In the restaurant industry, the fact that they're now faced with doing all these point of sale terminal things, that they want to add new things like maybe AI, maybe machine learning, but more importantly, they just want to do more apps so they can send their restaurant people out to the parking lot to take orders and to do new innovative things in this time that we live in.
Great. So where should a multi-domain orchestration platform be implemented?
Well, I'm biased, but at Equinix, the thing that we're talking about in the market is, so, and this has some reality to it. When we talk about doing multiple domains, whether the domain is at the infrastructure layer, whether it's Kubernetes or Docker or VM or Red Hat or OpenShift, right? Or whether it's at the application layer or the network layer, the question becomes is, can we do this in a place that has immediate low latency access to all of those things with lots of agile connectivity methodologies so that if we have to pivot, we can? So what we're seeing at Equinix is that these orchestration platforms are well suited to go into a metro edge location, that it can take advantage of the emerging micro edge sites that are being deployed to support 5G or MEC, but also have that dedicated private connectivity up to whatever hyperscale clouds that they need to gain access to, because we know customers are deploying their infrastructure across multiple clouds.
Great. Thanks, Rodney. So Greg, back to you now. What should we do when an SLA is violated? How do you address this?
Yeah, and that comes down to, once again, the ability to instrument, the precision of the instrumentation, and being able to get that data rapidly. An example is like a POC we did at one of the MEF events with a few providers, and basically an SLA was violated. So there was 3 operators, right? We could have like Bell and Tata and Tim Brazil that are delivering a service across the world for a user, a customer. And then there's a violation of the SLA. Now, which company was responsible for the violation, how the credits get sorted out, and how the penalties get sorted out, that's the type of scenario where automation is, where we prove that in the POC, can be used to determine this is when the SLA violation started, this is when it stopped, and then feed that into the settlement software, whatever, and it gets sent out. We're also seeing a lot of scenarios today where SLA violations are reported to orchestrators, and orchestrators are then used to either reroute or provide the SLA violation report to the operator or so forth. So once again, being able to react to that SLA violation live and what needs to be done to correct the situation, as opposed to having a report 30 days later that said your SLA was violated on Tuesday afternoon.
Got it. So do you think we should just monitor the end user experience? Do you think that's really all that matters?
And that's what it comes down to, because when we talk to our customers, and I'm sure JP or Rod, when they talk with people, it really comes down to the end user. When it comes to my network was doing great, my databases are in fine shape, it's all not that relevant. So what we're seeing more and more is the key performance indicator is the end user response time, the user experience. So we're taking multiple performance indicators, whether they're related to network, page load times, combining them and arriving to our customers with, here is your end user experience. And
Greg, we talk about end user experience a lot, and it certainly is clearly important because that's what everyone's managing to. But what about the places where it's a machine user experience, where that end device is just a machine, and you need to react to that too?
Yeah, the machine's the user, and I totally agree with you. So a robot's a user. My phone could be a user, right? The weather station in JP's backyard could be a user experience. Mm-hmm. So yeah, maybe I got to expand the word user. You're right there, Rod.
Yeah. All right, so Rodney, how does interconnection impact multi-domain orchestration for cloud-native apps?
Interconnection is paramount for multi-domain orchestration. When we talk about cloud native apps, let's talk about it in the context of the mobile operators, right? So as the mobile operators move from a non-standalone configuration to standalone configuration to support millimeter wave deployments and high density 5G deployments in metropolitan areas, one of the things that they're really going to have to pay attention to is latency. And in order to architect this so that end-to-end applications function, the thing that needs to then happen is what sort of orchestration tools, what multi-domain orchestration tools. Are we sure that a Kubernetes light configuration out in a MEC is actively got the right latency interconnect to the Kubernetes cluster that runs in, say, IBM Cloud? And that's some of the things that we're doing at Equinix to prove out that doing the domain orchestration at Equinix gives you that east-west or north-south sort of vantage point, whichever way you want to look at it. So we really feel as though that latency certainly matters, and latency always comes down to interconnectivity and your ability to agilely change that as needed.
Great. So can bare metal be orchestrated alongside other cloud offerings?
Yeah, in fact, that's the whole thing when we at Equinix acquired Packet and turned it into Equinix Metal. We at Equinix plan to stay on stack. We're focused on continuing to automate that bare metal. We're really wanting to make sure that we build an ecosystem that anyone who's got a domain orchestration solution, whether it's multi-domain or not, right? The point is that you can take different orchestration elements, run them on Metal, obtain your end goal, which is multi-domain orchestration, and not necessarily have it on the same infrastructure that's running your production applications or your production systems.
Great, thank you. JP, back to you now. Where will existing workloads moving to MEC come from?
I do believe that they will come from different places. So the first that comes to mind is the customer premise. So actually, a few workloads actually running on customer premise. I think about video surveillance, and we have a number of customers that run, servers and storage, in a closet somewhere, and it's a bit of a nightmare to manage, right? So if they can move some of those applications to a 10, 15, 20 MEC site to cover their geography, I think that's going to be definitely a lot simpler to manage and most likely reduce cost, overall. So when I look at some other application like gaming or connected manufacturing, right? A lot of the compute, is local to the user or to the players, right? So that's probably the first category. The second category is the workload that are sitting in the public cloud or private cloud today, right? So some of these workload, I think about some business application that do require so low latency that we're trying to we're doing workaround right now to provide the right latency. So I think MEC would be a good alternative for some of those. I think about IoT app as well that that might be moving from public and private cloud to the MEC side. I think the third category is probably the brand new workload, the one that we need to find a home for, like the connected car and AR, VR that are not really anywhere today. And so I think MEC is going to be the place to deploy these applications. So obviously MEC is not going to be the place for everything, and I think MEC is going to be a good alternative, to the other solution. It's going to be really complementary to the existing private and public cloud.
And just to tag on to that, JP, I've experienced some customers who maybe were doing their initial development of an app, and they did it, in the cloud, but the ultimate location for it winds up being MEC, where the development happens up in the cloud because it was fast, it was easy, and then they need to make that migration out as they deploy. So if they got a business process that needs to be deployed, but they're going to do it on a regional basis, either global regional or in-country regional, they start in the cloud and then they migrate it out to the location for production deployment.
But I think that y'all bring up good points, and one that like JP brought up is not all applications really need to be or should be in the MEC, and that's something sometimes we have to talk with our the folks we're working with to make sure we're having the right fit, right? So not. I
can tell you, Greg, that's a great point. Where performance measurement and management is really the only indication they have, unless they actually just put that app out there, go to all that work, orchestrate it, get it out there, and then they get the end human users to test it, and it has a problem, right? So can you get in front of that by having performance management in front of the MEC, over whatever the network is to start characterizing it? Can you do that faster and become more agile in the software development and the applications?
Yep. Yeah, you want to go in with these things with
Great
eyes
stuff,
wide
guys.
open. Yep.
Yeah.
Oh, thanks.
And anything more to add before we bring it to a close? I love all the cross chatter going here. Anything else to add?
I think one thing, just as a quick note, is anything worth doing. I learned this from a boss of mine many years ago. He said anything worth doing is worth measuring, right? Whether you're shipping products, whether you're building fences, whether you're farming, whether we're building networks, it's worth measuring. So as we talk about the MEC and moving things to improve latency, to have a better experience, we need to measure to make sure we're doing better as we go forward.
So how will we manage workload orchestration?
So first, I think it will be slightly different for private and public MEC. So from a private MEC, typically the service provider will provide APIs to integrate with the application stack, and on the public MEC, the hyperscaler who will provide a similar cloud experience, will provide as part of their solution that that orchestration capability. So if we do go one level deeper, so I think there's multiple level of orchestration required, multiple tier basically. So there's going to be the underlay, which is more the connectivity to the MEC side and provide that agility, I guess, from a connectivity perspective. There's the overlay, the SD-WAN or other VNF that you're going to run, at the MEC side. So typically the service provider, will provide that orchestration through, on our end, it's our NSO, which is the orchestration platform that we're using. And another tier, another layer is going to be the infrastructure. So either provided by the service provider or the hyperscaler, and then on top of everything, basically the application that is typically going to be provided by a third party or simply homegrown by the enterprise. So I think there's definitely a requirement to integrate the full stack, and bring the different layers together. And this is where I think there's an opportunity, and this is that's absolutely critical. So that the role of that end-to-end integrator, it's actually quite important, and I think it's going to be a different player depending on the use case. So the service provider might be that end-to-end integrator for some of the use case, while the enterprise might be the integrator for some other use case, and maybe the third party will integrate things together specific to an application in a vertical a space. So this is kind of how I see the orchestration.
Yeah, I would have to agree. Right. JP, what we're experiencing is that the end users today, especially with private MEC, right? So it's private. They're going to be using their tried and true orchestration tools. A lot of manual function, but they are looking to automation. So when we talk about workload orchestration, we have to talk about how it's going to be automated. Are they going to do Terraform? What tools are they going to use to automate those processes? And I don't know that we, from an Equinix point of view, yet have really got a clear understanding of how the end customers or the end users want to have their applications orchestrated. I think there's a lot of assumptions that are happening in the marketplace today. And to that end, there's a lot of testing to prove that the technology works. And I have a good sense that the technology works. One of the things we've done with one of the hyperscalers is to prove that that OpenShift can be managed from a cloud and put on Equinix's metal. Does that immediately equate to workload orchestration for an end user? Still open to debate, because there's a lot of security stacks, there's a lot of operational domain and things from an administrative perspective and security that we have to take into consideration. So I would agree with everything that JP was just saying.
Yeah, and Jeff, and if I can add to that, this kind of ties back to what we were talking about a bit earlier about, how can humans handle all this performance? We heard the complexity from JP of delivering the service. What if something goes wrong? Where do you start, right? This is where being able to have the proper KPIs, the segmented views, and having that all brought back to the orchestrator so it can decide, right, this is where we need to spend some time, or this part of the chain is not performing. So that was a good explanation, JP, to show the complexity of how this can be sometimes.
Multi-domain orchestration needs a place that it can be put so it can orchestrate all of the things across the full spectrum of what an end user is trying to do. Whether it's a mobile operator, whether it's an enterprise, whether it's a platform or a SaaS company, they need to be able to have a neutral place to do it.
And I would say that Mac is definitely complementary to the other options out there. So it's one solution. So
fantastic, guys! Thank you so much. That is gonna do it. That's a wrap. We really do appreciate you taking the time here to share all of your insights and expertise with us on this deep dive. So thank you, and thank you to everyone watching at home or at your office. More to come. All right, nicely done, gentlemen, and thank you for a closer look at the user journey to the edge and multi-domain orchestration for cloud-native applications, performance, and security across the ecosystem. Now, with our final deep dive of the day, our experts are taking us deeper into the demands of real-time applications and the role of analytics for customers and providers. The demands of real-time applications, smart data connections, streaming video optimization, and the flexibility to convert legacy and new protocols to support diverse industrial IoT use cases require ultra-low latency, real-time edge processing, protocol conversion, and even local triggering of actions in the multi-service environment. So how will analytics differentiate and demonstrate value to customers and providers? Today, we have three industry experts joining us for this discussion. Please welcome in Dibs Shekhar, Senior Development of Product Development at Comcast Business, Sylvain Courtier, VP Marketing and Product Strategy at Equinops, and Eitan Schwartz, VP Service Provider LOB North America, RAD. Welcome to all of you, and thank you so much for joining us today. Now, we always start off with intros, so if you would, let's get right to it. If you could share a little bit about yourself and your role within your organization, please. Let's go Dibs, Sylvain, Eitan.
Hi, I'm Dibs Shekhar. I lead the product development for ActiveCore SDN NFV platform at Comcast Business. I'm Senior Director there at Comcast Business, leading this service for the last 4 years.
Hi, Jeff. So I'm Sylvain Cartier, the VP Marketing and Product Strategy for Equinops. Equinops is a network vendor. We are doing hardware and software, and especially software for the edge computing domain.
Okay, and I'm Eitan Schwartz. I'm responsible for the service provider line of business here in the US and Canada. I've been with RAD for a long time, since actually 1991, and very involved in universal CPE and carrier Ethernet over the last 10 years.
Wonderful. All right. Well, thank you again, gentlemen, and welcome. So here we go. Dibs, let's start off with you. What is a multi-service environment?
Sure, Jeff. Multi-service environment can be defined in a couple of different ways, from infrastructure to applications to the different types of traffic that goes over the transport. Now, a better way to understand what multi-service is to visualize or think about what customers usually have in their branch locations. Typically, customers in their branch locations have got some sort of transport that can be a broadband or could be a fiber connectivity. Then they have some sort of VPN network that is connecting their sites to the corporate headquarters or to the data centers. And then you have some sort of network security. Security is paramount. Everybody has that. So it could be on-premise security or the cloud-based security. And then you have business continuity, because all your services, all your applications needs to have 100% availability. So that's your business continuity in the form of either LTE or some sort of wireless backup or some sort of multiple transport types that a customer can have. And then you have voice services. And then also the Wi-Fi services. Most customers have the Wi-Fi and the voice services. And very important piece where everybody, all the traffic is moving over is the cloud connectivity for their SaaS-based applications. So look at all of these things together, you know this is a multi-service environment. That's one way to kind of define what the multi-service is. And the other dimensions to this is on all this transport that we're talking about, you have multiple different types of applications that are running over without the congestion or having the right kind of quality that these applications need. Now, that multi-service environment, as we're talking about the SDN NFV today, is multi-service environment can also be virtualized. Many of these functions can be virtualized and be on the same hardware. But still, this is still a multi-service environment, even in this paradigm. So that's how we're looking at defining the multi-service environment.
Fantastic. Thank you for that. As a follow-up question here, can you speak to the challenges that customers and providers face with this multi-service environment?
Absolutely. The challenges, I think I would categorize the challenges in many different categories. And because the challenges are many within this domain, within this environment, the very first challenge, very first category comes out to be user experience and how do you troubleshoot the services within this multi-service environment, right? So main issue is all about within this multi-service environment, how am I taking care of my applications as well as my customer user experience aspect of the things. And given that the services are closely interlinked and they have so much dependency within them, it is very much possible that these services are impacting each other, which can be impacting the user experience and the application experience. The second category comes down to how are you taking care of troubleshooting this kind of services, which means what expertise do you need to troubleshoot these services if any problems is happening. The problem here is this expertise is no longer a tier 1 kind of expertise. You need a tier 4 type of expertise that is going from understanding, okay, if I'm having application issue, this is not just an application issue. It could be related to the network, related to the transport, related to the configurations within any of these kind of services that is there. And then the third category comes down to ease of access and use. Within multi-service environment, it is also the fact that you have many different vendors, many different application providers, many different products that are available within this multi-service environment. Now, how is customer trying to access these services? Are they logging into multiple portals? Are they logging into multiple individual products one by one? So how are you doing this, the identity management, the access management to allow customer to go to one single place rather than going to 10 different places, 10 different portals to log in? And the fourth piece is obviously about the managing the vendors. Now, you have multiple providers who are providing the services to you in this environment. How are you going to manage the vendors and how are you going to manage those products from the perspective of maintenance, the software upgrades, the hardware management, and so forth? And the fifth and the most complex aspect of all of this is the operational delivery, operational challenges that comes to from the perspective of service providers or from the perspective of managed service providers, right? And those operational challenges are also, if you categorize that, they're delivery challenges, because now if I have to install many services at a customer location, I have to look at coordination, the installation, the scheduling of all these services into one truck roll, or am I doing the multiple truck roll for all the services? Because if I do multiple truck rolls, I'm increasing my cost tremendously, right? So how do I manage that coordination to install all the services in one go? Then the second category within the operational support aspect of things is how am I provisioning the services? Because these services have interdependencies. So from the configuration aspect of things, I need to understand which service has a dependency and on the other services, which means if I have overlay services, we talk about overlay in the sense of like voice or the Wi-Fi or SD-WAN. These could be overlay services that are going over an underlay, which could be your broadband with your fiber and so forth, right? Now, there are dependencies between the two of them because now you have to set up your underlay services in such a way that it is optimized for the overlay services, right? So there's dependency that I need to know. There's a configuration dependencies that a service provider needs to know. So that there's a complexity that is added because of the multi-service environment. And the third piece is all about testing and automation aspect of the things, right? The services that I'm installing, operationally, I need to be able to test those automatically in an automated fashion rather than a manual fashion, right? So I need to have testing tools available that can do this automatically. And the fifth thing is basically customer support. If an issue comes in, how am I troubleshooting? How am I able to kind of get back to the customer in a way where I know is irrespective of whose service it is, I, as a service provider, it's a one throat to choke. So I need to be able to answer for and be able to provide the right kind of support. So.
Wow. All right. So a lot of challenges there for customers and providers. Dibs, thank you for taking us through all those. Eitan, let's go to you now. What is the difference between edge computing and network function virtualization, and how do you see them fitting into hybrid cloud environments?
All right, thanks, Jeff. And firstly, I loved Dibs' explanation. I'm going to maybe just zoom into one component of it where he talked about perhaps virtualizing some of the functions and the complexities associated with that. So firstly, what is Network Function Virtualization, or NFV? So this is about virtualizing networking functions. So these functions could be firewalls, routers, SD-WAN appliances, and so on. And then also service chaining these functions on a customer prem server or what's called a universal CPE. One of the advantages of UCPE is that it allows you to replace multiple physical appliances with a single device. Fewer components can sometimes help simplify the process. As Dibs said, fewer truck rolls. Edge computing, on the other hand, is more about providing computation and data storage capabilities, and providing these capabilities closer to the location where they are needed. So edge computing, or computing at the edge, is especially valuable when you want to improve response times, right? So you're going to be computing stuff right next to where it's happening, and it also can save bandwidth. You can think of the video streaming. If you can optimize it locally, you can save on bandwidth. Now, if you look at this typical networking slide, it kind of shows the environment that Dibs was explaining. There are many different kinds of businesses and verticals shown on the left-hand side, and each one of them have their own service requirements. To address all these different requirements, you really have to have very versatile hardware that is also very customizable. So going back to that branch office that Dibs mentioned, a remote branch office, sure, they'll typically require Ethernet and Wi-Fi user connections, as well as fiber or broadband network interfaces, and then perhaps LTE backup. Whereas other kind of locations, for example, IoT applications for say, smart city, they may require slightly different hardware. They may require a more ruggedized hardware. They may require different interfaces, perhaps LoRa wireless connection to sensors, pick up gunshot sound and make it into an event. So customizable hardware is very important, but it's also not sufficient. In order to simplify the management of the hardware and also all the functions that run over it, you need to have a powerful operating system that can support these two functions, NFV, so it can host VNFs, and also provide edge computing functionalities. Therefore, in this graphic, I'm showing edge computing and NFV capabilities handled at the customer prem, but it's important to note that these could also be handled at nearby gateways or data centers in the access part of the network or at the network edge. Also, when we talk about hybrid, multi, and distributed cloud, as I show, these environments, we're basically saying that the computation and storage should be provided on-premise, but it could also be at the service provider data center, or it could be in public or private clouds, or any combination of these locations, as is actually the case with our hybrid cloud environment. Back to you, Jeff.
All right, thank you so much, Eitan. All right, Sylvain, we're coming to you now. Got to bring up 5G here. 5G is coming with the promise to reduce network latency by 10. Edge computing is supposed to remove the network latency bottleneck. So isn't it in contradiction?
Yeah, good question, Jeff. Effectively, Edge computing is often seen as technologies to support the ultra-low latency use cases like gaming, like virtual reality and others. In reality, you know these old stories of the users complaining about application performance. Often, the first thing is they blame the networks. And now that we have 5G, does that solve all problems that we have in the application performance? In reality, not, because it's not just a question of networks. It's obviously a question of application running in the cloud. And with the cloud computing, the challenge that we had is we move the bottleneck to another piece in the cloud. With the edge computing, you bring the possibility to distribute that load into multiple edge that you load balance through the 5G networks. So the combination of both is very important to solve the latency problem globally, not just networks, but also on the computing side. I can give you an example that we had last year with in the connected car business, where in that use case, you have the car brands that is sending software update to the cars and collecting in real time data analytics from the car. They were doing that from a single cloud and over the radio networks. At that time, it was 3G, 4G, while the car is moving. So you never know if the car has a good coverage on the radio side. And at the same time, the cloud, which was one cloud for all Europe, was the bottleneck because you have more and more traffic, more and more data. Software update was software package bigger and bigger, data to collect more and more data. So they decided, which is very interesting, they decided to transform the car dealership place as an edge computing. So when the car comes for maintenance, they offload all the data to a system in the garage. They also upload the software update in the cars. And in that dealership place, we have a system here which is doing the pre-computing of data, really as an edge computing, and then send back that to the cloud at any time later on. So that's a good example of the usage of and the value of edge computing. We had also another one, which is quite interesting. It's in the fresh food grocery. So you can ask yourself what fresh food is doing with edge computing. It's a quite interesting use cases where that customers has multiple stores in France, and they manage fresh food price as a marketplace. It means that the price can change in less than 1 minute. And the price has to be updated live in the stores. And of course, when a consumer take potatoes from the store, 30 minutes will pay it has to pay the price it was 30 minutes before. So it's completely crazy use cases, but in fact, when you think about it, you need to update the price real time. They add also some cameras to capture the price live and send that back to the cashier. So you have a lot of computing in the stores that is also backed up with the marketplace pricing in the cloud. So here again, you need a local computing close to the source, and that justify that you combine, 5G networks and local computing to allow those use cases happen.
Wow, really interesting. Thank you so much for sharing those examples too. It's great. All right, Eitan, let's go back to you. If you would, sir, could you please provide an example of how edge computing pairs with networking functionality, such as security, SD-WAN, and wireless technologies?
Sure. Firstly, I love that supermarket example. I have a lot of issues where they don't have the right pricing and having to send somebody back to check what price is written there. It'd be great if it was all automated. But going back to my question, so there are many other applications that can benefit from edge computing, and then most of them require secure and redundant connectivity over wireline and wireless networks. For example, a bank branch may need secure network connectivity for their regular business traffic and transactions, but they also may need it to control access to their building, provide redundancy for their alarm systems, and so on. So imagine such a branch, they probably have some ATM machines and video surveillance that could also benefit from edge computing to optimize and store surveillance video streams locally, but also separately from the more vulnerable cameras, maybe in the back office, right? And then they could also simultaneously forward only what's relevant over the network. And in that case, save bandwidth, right? If the store is closed, there's no movement, no need to continuously stream traffic back to the cloud. Other examples can include retailers. Perhaps they'll use edge computing and sensors to track inventory. Maybe farmers. They can use sensors to monitor soil and environmental conditions. And then they could actually even do local compute actions, for example, turning on some sprinklers. Another example is industrial manufacturing. So those kinds of companies, oil refiners, all of these companies that are collecting data from sensors. You can imagine drill bits or manufacturing equipment that if it starts to vibrate, it starts to indicate that it requires a maintenance window, right? If it's making a loud noise. So if sensors can pick that up, you can take action before damage is caused. So you can collect that information, if you can do it locally, if you can analyze it, and then immediately and actually autonomously, irrespective of your connection back to the cloud, take action. Like, for example, shut down industrial equipment to prevent catastrophic failures when safety parameters are exceeded. So if we go back to that slide again that we showed earlier, we can now see how customer prem equipment is really important. It not only provides that local Ethernet and Wi-Fi support, but also it provides the IPVPNs, the SD-WANs, the firewall for connectivity, both to the service provider and ultimately to the clouds. And then for the industrial IoT use cases, it helps for the CPE to have additional interface options, such as LoRa, as well as ruggedized options. And finally, the edge computing is key because it provides the flexibility to run different third-party software. We have so many of these cases in our critical infrastructure where there are companies that have perfected software that knows all kinds of legacy sensors in buildings and so on. So you can run that third-party software locally and provide functions such as protocol conversion, predictive maintenance, and video stream optimization. And so just to end off, if we zoom into the solution slide a little bit further, we see how there would typically be an operating system running on various hardware options. This is considered the disaggregation model, where you can have a single operating system and a variety of hardware platforms, and in this way address multiple businesses and industrial IoT use cases. And then going back to the operational issues that Dips mentioned, you want to be able to do this with consistent automation, lifecycle management, networking capabilities, and so on. Thanks. Back to you, Jeff.
That's great. I'm just loving all of these real-world examples here. Talking cars, supermarkets, retail, banking, industrial manufacturing, so many applications here. Thank you so much for that, Eitan. Back to you, Sylvain. So SASE, SD-WAN, 5G, NFV you mentioned. How is everything linked to edge computing?
Yeah, so they are linked in many ways. If you take SASE, for example, it's really where, in fact, the branch and the edge meet together. We said in that the title of this event is "Bring Back the Cloud to Earth." It's exactly about that. SASE, that is the security features that is now extremely demanded by customers, is about securing the branch with cyber security features that can act locally by studying and analyzing the traffic and eventually block a traffic that is not something suitable for the networks. So it can act locally, but also many SASE features are coming from gateways that can be hosted in the edge and act in real time, close to real time, to bring a more intelligence to the branch to take some decision. So SASE, gateways, edge are very much together. SD-WAN is closely the same. SD-WAN story is about to create overlays and connect branch together, connect two stores, two bank office. together. So obviously, you do not connect directly both together. You're going through an edge, through gateways again. And here, you will have extremely good latency if you manage to get this edge the closest of those branch side. So here as well, edge can help the SD-WAN use cases. 5G, we took already some example for 5G. But at the end, what is very, very key on 5G is contrarily to 3G, 4G that were considered as backup networks for the enterprise when the primary networks have an issues. And now 5G is really considered as the primary networks in many cases. So 5G will become a predominant technologies to link the branch with the edge in any industry.
Great, thank you, Sylvain. Eitan, back to you. Why is edge computing and IoT important for service providers?
Well, firstly, edge computing is fast becoming a very popular way to enable new enterprise services. We spoke about a number of them here, the supermarkets and so on. So it's new enterprise services and use cases. And I think this is especially in the IoT and industrial IoT spaces. Both edge computing and IoT are forecast to be huge markets. I've looked at studies that talk about them approaching trillion-dollar valuations with thousands and even millions of sensors per project. So this is a perfect opportunity for service providers who can leverage their existing infrastructure, their networks, their data centers, as well as their relationships with enterprise customers. It is, relevant to cellular providers as they build out their 5G, but also for other service providers leveraging wireline and wireless options, such as fixed wireless, CBRS, and LoRa. So I see edge computing as a great opportunity for service providers to target services to verticals, such as smart city, connected industry, connected buildings, the transportation, smart roads and so on, utilities, lots of different kinds of utilities, smart meters, things like that, smart agriculture, and so on. Finally, I think it's important for service providers to be able to negate competitive industrial IoT threats. And this could be coming from private wireless and over-the-top type alternatives, such as IPVPNs and SD-WAN directly over the internet. Thanks.
Okay, thank you, Eitan. Sylvain, we're coming to you for a quick question here, and then Dibs, we're back to you to bring us home. So Sylvain, when and how will the edge computing economic model match the expected value?
Good questions. Economical model is the beginning of everything. If you want to reach a mass market and mass adoptions, that economical model must fly. And I see three conditions. The first one, on the technical side, we have to find solutions to be sure that we can maximize the performance of an edge with a minimized hardware capacities. And we have seen some use cases in the past, especially in the virtualization domain, where there were so much demand of resources, it's difficult to get a viable economical model because of the cost of the solution. That's the first point. The second one is simplicity. Simplicity is absolutely key. Again, it's a good parallel to study what happened from the virtualization, SDN and AV world, where at the beginning the use cases were so complex, it was difficult to match really a business value of it. So simplicity will be very important on this aspect. And last, obviously, it's the value that you get on the use case. So here with Eitan, we have shared few use cases that really demonstrate the value of it. And again, I think the example of virtualization is very interesting. The promise of virtualization 8 years ago was to have a kind of service stores that you can download on your branch at any time. It won't work really, but today virtualization has definitively found its place with the branch consolidation, with a very easy model to merge multiple services in one box in an easy way. And I think when we will see some simplicity, value proposition, and a good match between software and hardware and edge computing, it will be massive. But definitively it will come. We see now, at the beginning it was always gaming, virtual reality, but now we start to see connected cars, groceries, banking, industry use cases. So definitively the economical model will fly very soon on the edge computing side.
All right, good stuff. Thank you, Sylvain. Dibs, the final question is yours. How do we differentiate with analytics in a multi-service environment?
So I was listening to what Eitan and Sylvain were talking about in terms of edge computing and the IoT. The major use case there is obviously about analytics. How are we deriving intelligence from the data collected by the sensors and the smart meters to come to a decision? Now, how we differentiate with analytics, the first thing to understand is what are the challenges that we see today? And the biggest piece that you're going to have is the velocity and the volume of data that's coming from all these different types of meters, the sensors, the network by itself. So in a multi-service environment, the major use cases that analytics will offer, and those are the differentiation in that regards, are how are we collecting the information? How are we aggregating the information? How are we correlating and building the dependencies and the context of all the data that has come together from different types of providers, which is providers in this case, different sensors, the meters, and so forth. And how are you building the visibility for each of the applications and the user experience from this data that you have collected? Then it's more about the intelligence. So application intelligence, network intelligence, intelligence for the different verticals and the segments that you have to create from the data that has been collected. And this is where the AI, the ML aspect of the things is where the differentiation lies. And then the big piece is the biggest use case, which is differentiating, is the early warning kind of system. So irrespective of the vertical, what are the early warning systems that you want to build in so that everybody becomes proactive, whether it's a customer, whether it's operations, whether it's a providers, you need to build early warning systems for different types of use cases, whether it's applications, whether it's IoTs, whether it's any kind of retail segments that you have. And then the root cause troubleshooting, right? The biggest piece is the root cause troubleshooting. How the AI and ML can enable the root cause troubleshooting where it is prioritizing all kinds of issues that is happening in the network, but it's only giving you the top 5 or top 6 that are service impacting and allowing you to kind of predict and prescribe what that issues can be. So that's the way we see the analytics to be the differentiation in the marketplace. Back to you, Jeff.
All right, thank you so much, Dibs. And with that, that's going to do it. That's a wrap. We certainly appreciate you sharing your time and talent with us today. And to everyone watching, we hope you enjoyed this deep dive. Looking closer at the demands of real-time applications, a perfect way to close out our show. Thank you, gentlemen, and thank you once again to our audience for tuning in. From exploring the landscape of our collective digital transformation to SD-WAN, to empowering enterprises with innovative solutions like SD-WAN, to the latest developments in the SASE market, and frictionless, high-performance, low-latency benefits of edge computing. We are excited to take things to the next level. It's a lot to balance, but we're doing pretty well. Don't forget to tune in to our next episode, 5G Slicing and Dicing the Future from End to End, airing May 12th. You don't want to miss it. Until then, stay safe, everyone, and we'll see you back here as we continue to explore the infinite possibilities of the digital world across the network core, the cloud, and as always, the edge. And I'm out of here.